Hello guys, Mr. G here with another video for the grade 10th. This is going to be question 9 from 2013, a question paper done at the Northern Cape. It was a set B, and before going on, please subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question says use the key below to answer the question which follow, and the key below is just a block which will have oxygen atom and hydrogen atoms. Okay, now hydrogen peroxide decomposed to form two products. The following is a simplified diagram for this reaction. Remember, we spoke about decomposition and synthesis in previous videos. So what is going to happen is that this one here is going to break into different type of substances. Okay, write down the chemical formula for hydrogen peroxide. Now hydrogen peroxide, if you go to the reactant, is going to be the combination of two oxygen, as you can see here. This one is oxygen. If you go back to the keys they gave you, the big ones is the oxygen. Let's do this one for us to understand. That is the oxygen, and the small one is a hydrogen. So let's, for instance, say this one is hydrogen. So you have here, and then you have a combination of two oxygen with two hydrogen, guys. And if you go to the other molecule, this is just showing you that there are two molecules there. It's two oxygens with two hydrogen. Saying that, what is the formula? It's going to be H2O2. Very simple, max. Use the table below refers to the use the above mentioned reaction. I don't know why that is in that way together. Use the attached answer sheet to complete the table. Okay, so we have to answer this table. Name of the substance. And we're going to start answering this one. It's quite simple. This one is hydrogen peroxide. Hydrogen peroxide, that is the substance. Number of atoms of oxygen, they are 4. We're talking about the reactants, so be careful. If you go to reactant, you have 4. 1, 2, 3, and 4. You have 4 atoms of oxygen, so it's 4 there, and you have 4 as a total here. Now the hydrogen, you also have 4. We're talking about reactant. If you go there, so you have 4 and you have 4. Number of molecules. Now the molecule here, I want you to be careful there. Let me just erase these little numbers I make here, because I want to show you something, guys. All this one here is a molecule. So this one is one molecule of hydrogen peroxide, and this one here is another molecule of hydrogen peroxide. So there are 2 molecules. There are 2 molecules. Okay, so that is what we have to answer here. How many molecules are there? There are 2 molecules in total, and there is also, the total is also 2. Name of the substance of the product. Now we go back here. Here we have the combination of 1 oxygen with 2 hydrogen. There we go. And then at the bottom is the same. We have 2 hydrogen with 1 oxygen. And then the other substance you have is 2 oxygen together. So what we have, this one here is H2O, 1 oxygen, 2 hydrogen, and you know it is water. And here is 2 oxygen, so it is O2, and is oxygen gas, because oxygen is gas at room temperature. Okay, so that is all, guys. So name of the substance, we have here water, and we have oxygen. Let's start with the oxygen, and then we also have water. It's very simple. Number of atoms of oxygen in total, we have 1, 2, 3, and 4. That is in a total, but they don't want the total, they want the number of atoms in oxygen. There are 2 atoms in oxygen, and there is 2 in water. You can see there, you have 2 atoms there, and you have also 2 atoms on this side there. So it's 2 and 2. The total is going to be 4. Number of atoms of hydrogen in oxygen is 0. There are 0 atoms of hydrogen in the oxygen molecule. You can see there. And then you have here 4. Total is 4. And the number of molecules of oxygen, as we explained before, this one here is one molecule, this one is another molecule, this one is another molecule. So number of molecules of oxygen gas is only 1, as you can see there, and of water is 2. The total number of molecule is 3, and that is the combination of the completion of this table. Is quite simple and is very good. What do you observe with regard to the number of atoms of reactants in comparison to that of products? And this one is quite simple. All you have to say is they are the same number of atoms. Okay, what is illustrated by your observation in 9.2.1 above? There was conservation of atoms. Number of atoms stayed the same. What do you observe with regard to the number of molecules of reactants in comparison to the of the product? You can see that the number of molecules in reactant is 2 molecules, but in the product is 3. So it's not the same number of molecules. What conclusion can you make from the observation in 9.2.3? And here we can say that molecules are not conserved. You can say that molecules are not conserved. So that is quite simple there. Question 9.3. Write the balance equation for each of the following chemical reactions. Sulfur burns in oxygen to form sulfur dioxide. Very good. Very good, guys. Very good indeed. So 9.3.1. Now sulfur. The symbol for sulfur, guys, is just S. Sulfur is a solid. Sulfur is a solid. I don't think you have to write the states here. It's not part of this question. Now, when they say burn in oxygen, all you have to do is to add oxygen. But oxygen is always a diatomic molecule. So it's O2. And guys, that question was previously in one of the other questions there, that oxygen is a diatomic molecule. So I'm going to make a note here. Oxygen here is a diatomic molecule. It's a diatomic molecule, so it's O2. Now, what do you have as the product? Sulfur dioxide. So it's SO2. Now, this one is the reaction. For doing that, you will get marks. But this is not the final answer. We have to balance. The conservation of atoms must be there. Alright? So you have to make sure it is balanced. You have one sulfur in the reactant and you have one sulfur in the product. That one is correct. You have 2 sulfurs in 2 oxygen, in the reactant and 2 oxygen in the product. Guys, this question is done and dusted. Question 9.3.2. 9.3.2. Magnesium burn in oxygen. Same story. So now magnesium, which is a Mg, is going to burn in oxygen. Remember, you say plus O2. Alright, and then it's going to give you magnesium oxide. Remember, there is a video on writing formula of compound for magnesium. I'm going to write it on this side here. Magnesium is a Mg2 plus and oxide is O2 minus. They swap places there. The 2 swap places there. One here and the other 2 there, and then you will have Mg2O2, but because they are the same numbers, they cancel each other, and then the answer or the final answer will be MgO. That is the product we're speaking about here. It's MgO, and then we have to balance this one. We're starting with magnesium. We have 1 magnesium on the right hand side. You have 1 magnesium on the on the left hand side. You have 1 magnesium on the right hand side. Oxygen you have 2, then you have only 1 on the right. Remember, the numbers to balance must be added at the front. You add the numbers at the front to balance, and that will affect everything that is coming at the back. So now we're having 2 magnesium and 2 oxygen, but however the oxygen is sorted. We have 2 oxygen on the reactants, as you can see here, and you have 2 oxygen which is at the front in the product. But magnesium changed because we have now 2 magnesium here but only 1 on the reactant. So all we're going to do is to add a 2 there at the front. Guys, this one is the end of the video. This is the question 9 of this question paper. I hope it helped. Subscribe for the channel so you can get all the notifications and videos I post. I'll see you next time. Mr. G here.